So we now start talking about what is the number of molecules within this volume. So you see, have a look here, but number of molecules in a volume, how much volume? V equal to pi d square lambda. We have already found this, I am just writing it. So number of molecules in a volume V is okay. How do we find it? We have to find n, right? Number of molecules. Okay, so to do that, we will use this idea. Have a look. PV equal to mu RT. Okay, therefore P into V equal to n upon Na into RT. I am sure you understood that step, right? P into V equal to n upon Na into RT, because number of moles is n upon Na. So that gives me that value of n should be equal to P into, okay, sorry, P. And now on left side I am going to do something here. Have a look. This I can also, sorry, on the right side I can also write this as, did you get this? R upon Na. What is R upon Na? It's Kb. Clear? So this can be written as P into V. Okay, this can be written as n equal to P into V upon Kbt. Is this fine? Okay, now I am going to put the value of V. So what's the value of V? Pi d square lambda divided by Kbt. Right? Okay, all this clear? Finding the value of n, is that clear? Right. Okay, we started with ideal gas equation and then we did a few simplifications to the equation, so we got this. Now this is it. So what have we found? How many molecules are there in this much volume? How many? Okay, so we have got this answer. It has this many molecules. Now listen to what we started off with. We said that before hitting the next molecule, going from A to B, right, that's where it makes one collision. So this distance is nothing but mean free path, lambda. So we just have to find lambda from this. And because we are talking about mean free path, again, what is mean free path? Recall its definition. Distance traveled on an average between two collisions. So here, when this dawn moves from A to B, can you tell me how many collisions it made? Can you tell me how many collisions it made if this distance is mean free path? If this distance is mean free path, how many collisions did it make while moving, or in the time it moves from A to B? One. It is one collision. Okay, mean free path kone kehvaય? The distance traveled between two collisions. So when it goes from A to B, it's going to make one collision. See, some people get confused by this. I understand. Have a look at this example. Can you tell me 10 o'clock, that is 10 a.m. to 11 a.m. is how many hours? 10 a.m. to 11 a.m. is how many hours? Yes, it is 1, right? Okay, so just like that, if you are going to consider that this 10 a.m. was in previous, and if you are going to consider that 11 a.m. is in the next, તો તમને એવું લાગશે કે આ તો કઈ ટાઈમ જ ન થયો, but that's not true, right? It's just like counting numbers 1, 2 and 3 and like that. So between 1 and 2 you have a gap of 1, not 0. I hope you understood that. Between 1 and 2 you have a gap of 1. So we say that as distance traveled by this molecule, is mean free path, that is lambda, n should be equal to 1. Did you understand this? Because number of molecules in that volume is same as number of collisions. Refer this line. જેટલા મોલિક્યુલ અંદર છે એટલામાં એટલા કોલિઝન થાય તો કેટલા કોલિઝન થયા? 1 collision. While it goes from A to B, when it goes from A to B, it has 1 collision. Yes, exactly. Right? So there is 1 collision. Now if there is 1 collision, that means this distance is mean free path. N equal to 1 મૂકી દીધું, because number of molecules in that cylinder, આખું જે સિલિન્ડર હતું, ઓકે, એની અંદરના મોલિક્યુલ્સ અને એના કોલિઝન્સ. Yes, it means that there is only 1 molecule except don't forget. It means that there is only 1 molecule on an average in that. નહીતર તો વધારે કોલિઝન થાય ને, એક જ મોલિક્યુલ હોય એટલે એક કોલિઝન થયો, વધારે હોત તો વધારે થાય. ઓકે, so n is 1 because there is only 1 collision, right? So that means n is 1. Now if I put n equal to 1, I will get 1 equal to p pi d square lambda by kbt. Understood this step? This is equal to 1. Okay, now that's it. We have got value of lambda. See? So lambda is equal to kbt by p pi d square. Are we getting a formula? So this is the formula for mean free path. Okay, kbt by p pi d square. What are all the terms? kb તો તમને ખબર છે, Boltzmann constant. T for absolute temperature, P for pressure of gas, D for diameter of molecule, no, I can't teach on on board, sorry. Okay, I want to teach on laptop. I don't know what's the problem with that. Everyone else is, appreciating that, but if you have some problem, you can, contact the school personally. So can we put n equal to 2, 3, 4? No, you can't. Right? You cannot put, it's not like you have to write 1, 2, 3, 4. No. Like I said, in this much volume, it made 1 collision. That's why we are writing 1. If it was writing 2 collisions, we would not be calling this lambda. Lambda કોને કહેવાય? Distance traveled to make 1 collision. Okay. So that's it. This is the formula for the mean free path. Okay. Now there is another thing here. When we derived it, P is pressure. બધા pressure એક જ હોય. Riya. Pressure cannot be applied on molecule, remember. Pressure is a property of a system. Right? So lambda is derived like this, okay, but we made an assumption. I was telling you that when we took a cylinder, याद હોય તો hopefully याद જ હશે. I was telling you that when we took this cylinder, we assumed that if there is any molecule, it is stationary. याद છે? I also told you that there would be a lot of complicated mathematics if it was not stationary. याद આવ્યું? So now the time for that result. If the molecules are not stationary, okay, if the molecules are not stationary, then we don't get this formula, we get a slightly different formula, right? Okay, and it is lambda equal to kbt by root 2 p pi d square. Okay, if the molecules are not assumed stationary, that is, if we do a more rigorous calculation, then we get that the mean free path value is slightly different, right? So instead of just getting it that way, we get a different formula where of course all the terms are same, right? The terms are same, okay, but અરે ગ્રેસી મેં તમને પહેલા જ સમજાવ્યું હતું, it is way beyond the maths level that you can handle. ઓકે, એટલે એ વસ્તુ કંઈ રૂટ ટુ કેવી રીતે આવ્યું એ ક્વેશ્ચન પૂછો તો હું એનો તમને આન્સર સમજાવી શકું એમ છે જ નહીં. ઇટ્સ નોટ પોસિબલ that you will be able to get it at this level. Okay, so again, no questions about this. I'll just make it clear here, right? There is a lot of statistics and a lot of integration going on over there, right? ત્યારે એ આવે kbt by root 2 p pi d square, which is actually the correct formula. Mind well, this is a more appropriate or the correct formula, right? Okay, but like we have seen it often in physics, the more correct you try to make it, the more complicated its derivation gets, right? એ તો યાદ જ છે તમને. So in exam, you would have confusion. સાંભળી લો બરાબર. In exam you would have confusion. Okay, I've seen that sometimes in NEET or JEE exams they give answer by this formula, but some other times they give answer by this formula. Both the formulas are mentioned in your book, remember. Okay, so which one to use? It's always going to be confusing, right? So you would have to try it by both the methods. If you don't get the option, then you try the other one. Okay, if both are there in the options, it's always going to be debatable. Okay, in that case you will have a lot more trouble, right? I cannot do anything with that. કારણ કે સાચી formula આ જ છે, there is no doubt about this one is true. Okay, so you can lean on towards this one, okay, because we know that it is better compared to that. Okay, so this is a simple derivation, lambda equal to kbt by p pi d square. A more accurate one is lambda equal to kbt by root 2 p pi d square. Okay, now we are going to solve a couple of questions related to this, right? Okay, we'll solve a few questions to understand how this thing behaves. Mean free path. Okay, काम करे, चलो पहला relaxation time ने બધું derive कर दो, एक બે step માટે શું બાકી રાખો. So now let's go to relaxation time. What is relaxation time? Hopefully you remember, it's the average time between two collisions. So do you agree that this molecule, when it goes from A and to B, it makes one collision? So if we find how much time it took to go from A to B, that should be nothing but average relaxation time. કારણ કે આપણે already બધું average જ લીધું છે. Did you understand this? Or just tau? I don't know what I wrote. Hopefully you still remember the symbol. Okay, tau is the symbol of relaxation time. So bas એ જ find કરવાનું. So I'm going to treat it very simple. Between two collisions, this molecule moves with constant velocity. Yes or no? Okay, only when force is applied the velocity will change. So between these two collisions the molecule just goes from here to there without any change. So I can easily write T, which is equal to tau equal to distance traveled or displacement divided by V. Clear or not clear? V for velocity or speed. Yeah, understood? અરે બહુ અઘરું લાગ્યું? આવડી ગયું ને? v equal to distance traveled by time taken. આવું તમે કરો છો. If it's constant we can do this, don't forget. મેં તમને નાઈ પાડી છે અને મેં તમને કીધું છે ક્યારે થાય ને ક્યારે ન થાય. So distance traveled is lambda here and time is tau, એટલે એની ઉપરથી રિલેશન આવ્યું tau equal to lambda by v. Now because we want to find the average relaxation time, તો અહીંયા જે સ્પીડ મૂકવાની હોય ને એ રીતે કંઈક એવરેજ જેવી મૂકવી જાય. I'll repeat. As every molecule has different and changing value of v. I hope you understood what I have written here. As every molecule has different and changing value of v. બરાબર ને? બધાની v ની વેલ્યુ સેમ ન હોય અને v ની વેલ્યુ તો કન્ટિન્યુઅસલી ચેન્જ થતી હોય. So we should take VRMS. So for average relaxation time, we should put v equal to VRMS. Did you understand this? We should put v equal to VRMS. કારણ કે RMS એટલે કે એવરેજ ટાઈપની સ્પીડ છે. So that's it. પતી ગયું આનું ડેરિવેશન. Therefore tau equal to lambda. What is lambda? હમણાં જ આવ્યું હતું kBT by p pi d square. આપણે જે ડિરાઈવ કરી છે ને એ જ ફોર્મ્યુલા લખું છું અત્યારે. ઓલી લખો તો અહીંયા √2 આવશે. ઓકે, સો ધીસ ઇઝ લેમ્ડા ડિવાઇડેડ બાય v, but v is now VRMS. What is VRMS? Under root 3 kBT by small m. Okay, so if we write it like that, so this divided by under root 3 kBT by m. So this becomes kBT into root m upon p pi d square into 3 root of kBT. So if you take all of this under a root, you will get this as follows. This root kBT will be cancelled here, so you'll get root kBT m divided by p pi d square and a root 3. Did you get it? kBT cancel થઈ ગયું રૂટ માંથી. ઓકે, પણ આટલી મોટી યાદ ન રખાય. I would say don't put burden on yourselves. એના કરતા keep it simple. આ સમજી જાઓ what is relaxation time it will take to go from here to here to make one collision. તો આ કેટલું easy છે. પછી આમાં ખાલી v equal to VRMS મૂકી દેવાનું. Understood? Right? So that is actually a very simple way to do it. ખાલી ખોટી નવી ફોર્મ્યુલા ગોખવાની ટ્રાય ન કરતા. Okay, keep it simple. So that's relaxation time. Let's go to collision frequency. Again, collision frequency means number of collisions that one molecule makes in 1 second or in unit time. So જો કેના જેવું છે, if you just do some cross product, time and number of collisions. So if the number of collisions is 1, then the time is called relaxation time. Is this okay? એક collision કરવામાં કેટલી વાર લાગે? That is called relaxation time. Right? After how much time does one collision occur? Then how many collisions in one time, unit time? That is called collision frequency. Okay, this cross multiplication clear to you? I hope people are still not thinking કે અહીંયા 2 આવવું જોઈએ. અહીંયા 2 ન આવે, અહીંયા 1 જ આવે. Okay, how much time is there between 4 and 5? It's 1, not 2. Okay, so this is going to give you Fc equal to 1 by tau. Clear? This is clear. Fc equal to 1 by tau. બસ તો આ રીતે કોલિઝન ફ્રીક્વન્સી, આની કંઈ ફોર્મ્યુલા યાદ રાખવાની જરૂર નથી. આ ઓલાના જેવું છે, યાદ આવે છે, ફ્રીક્વન્સી ઇઝ 1 બાય ટાઈમ પીરિયડ, મેં તમને લખાયું હતું. ઓકે, ઇટ્સ અ સિમિલર આઈડિયા. ઓલ રાઈટ then. So this is collision frequency, right? Now let's just calculate this, right? Okay, I think there's a question in the book. Okay, question, last question if I'm not wrong from the exercise. Take your book out. Well, I don't have my book today. Take your book out, come on. I think last question in the exercise, I mean not the additional one, એને તો જોવાની જરૂર જ નથી. Yes, got it, that's it. Question 10 છે મારી બુકમાં તો. Question 10. Here we are. Okay, so the question is estimate mean free path, okay, and collision frequency for a nitrogen molecule, N2 molecule, nitrogen molecule N2, and at what 2 atm. 2 atm any value છે? 2 atm is, okay, can you all hear me loud and clear? Okay, 2 atm is pressure, very good. P is 2 atm, but remember we have to convert it to SI. So 2 atm is how much in SI? 2 into 1.01 નહીં લખો, ચાલશે 1 જ લખો. 1 atm is 10 raised to 5 Pascal. Hopefully you still remember that. ચલો, આ પ્રેશર થઈ ગયું. ટેમ્પરેચર 17 degree Celsius, but we don't like degree Celsius, we'll convert to Kelvin. So that's going to be how many Kelvin? Yes, 290 Kelvin, that is right. So 290 Kelvin here. Now let's put all these values. See, one thing that I have noted over the years, listen to this carefully, is that if the question says estimate, okay, so it's like you just have to get an approximate value estimate, then normally people use the formula without root 2, that is they use this formula. Did you understand what I'm saying? Okay, that's what I've seen, right? It's not like a rule, but that's what normally people do. Okay, એટલે જ લખ્યું છે estimate. Again, there is no guarantee that you will get the right answer, I mean the answer at the back, okay, because there's always going to be this confusion. Yeah, never mind, let's solve this. So lambda is this. अच्छा, एक वस्तु हजी જોઈએ, diameter, radius of nitrogen molecule is 1 angstrom, so diameter is 2 angstrom, that is 2 into 10 raised to minus 10 meter. Okay, so now we have all the values, we just have to put it. You have 1 minute to find out lambda, hurry up. Use the formula, lambda equal to kBT by p pi d square. Yeah, do it fast, come on, find out lambda, find out the mean free path. Hurry up, come on. Done. Okay, I don't know what happened here. Hopefully you did it, right? Okay. So what's the answer? What's the answer, people? अरे बहुत धीमा. How you answer? Please write it. No, Resha, that's too big. Ankita, that's too small. Priyansh, your answer is in the right range. Okay, so very likely correct. Raj, are you sure? Don't you think that's bigger than the size of Earth? So I think people are getting the number like about 1.6. Okay, I think you all are getting about 1.6 into something, right? હું કરી નાખું છું હવે કેલ્ક્યુલેશન કરી નાખું. I'll open my calculator in here. કેવું easy પડે. 1.38 into 290 divided by 2 divided by 3.14. Okay. 4. So hopefully you all did it now. I'm getting 15.9 first of all from the calculator, and into 10 raised to, this is going to be 10 raised to minus 3 and minus 8. So 1.59 into 10 raised to minus 7. આવું આવે 1.59 into 10 raised to minus 7. Okay, right. So you see how small this is. Try to get a meaning out of this. It means that a molecule, it travels how much distance on an average before it makes next collision? It is 0.159 micrometer, right? Although we say that gas has lot of empty space. Do you remember that molecules only occupy less than 1% space? But still, whenever a molecule will try to move, because there are so many molecules, and that is, it will just move a distance of 0.1 or 0.16 micrometer and it will hit, right? There will be a collision. Now let's go to collision frequency, FC. FC is 1 upon tau. ના -9 નો આવે, બરાબર જ કર્યું છે. Okay, so 1 upon tau is equal to, if you write tau, what was tau? It was lambda upon v. Did you get this? 1 upon tau is v upon lambda, and v ની જગ્યાએ શું લખવાનું? VRMS. Understood? Clear or not clear this step? This is clear? ઉપર ફોર્મ્યુલા લખાવી હતી, જોઈ લેજો. So this is equal to lambda તો મળી ગયું છે 1.59 10 raised to minus 7. Now we have to find VRMS. VRMS कैसे find कराए? Under root. No problem, Priyansh. I will talk about that a little bit later. So we have under root 3 kBt. divided by temperature 290. ઓકે, તો એવું કરો, પહેલાં VRMS સેપરેટલી ફાઇન્ડ કરી લો, પછી ડિવાઈડ કરીએ. ઓકે, એન્ડ just one moment, Priyansh told me that he checked the answer at the back, and at the back the answer is given by √2 here. ઓકે, હું બીજી વાર નથી કરવાનો, તમારે કરવું હોય તો કરજો. Like I said, it's always going to be a problem like this, right? Understood what I said? તો આ આન્સર ચેન્જ કરશો ને તો અહીંયા એટલો ચેન્જ થઈ જશે. Does that make sense? Because lambda's value will now have √2. તો એ તમારી રીતે કરી લેજો, બરાબર. I am not going to repeat. આપણે ખાલી આટલું કરી નાખીએ, બાકીનું તમારે કરવું હોય તો કરજો. Come on, find out this VRMS and divide and tell me what will be this answer according to this calculation. હું તો કરીને રાખું છું, 1 મિનિટ પછી હું આન્સર બોલી જઈશ. ઓકે, I hope you will do it fast. You can use calculator for such numbers. ઓકે, એમાં કંઈ મોટી વાત નથી, કારણ કે આવા બહુ રેરલી આવશે નીટમાં. અજેરેબલીમાં, સોરી. Be careful when you take square root. Okay, yeah, I've made a mistake here. I'm so sorry. જોજો અહીંયા જરા, √3 kBT એવું આવે ને, બાય એમ આવે. શું કરું છું મેં, ફોર્મ્યુલા જ ખોટી લખી. √3 kBT by m for mass of nitrogen, what is given 28.0 આપી દીધું છે. Okay, yes, m will be 28. Now see, this is where the problem arises with this formula. તમે kBT થી કરવા જાઓ ને તો આ પ્રોબ્લેમ શું થાય? Do you know 1U is how many kg? ખબર છે ને કે નથી ખબર? Do you know 1U is how many kg? Same as mass of proton. Mass of proton તો યાદ છે કે નહીં? Did you understand? Okay, આવ્યો કે નહીં આન્સર? ચલો વાંધો નહીં, હવે કેલ્ક્યુલેશન તમારી રીતે જોઈ લેજો. રાઈટ, you all are not interacting enough. I don't know what you are wondering about. ચલો વાંધો નહીં, થઈ ગયું. So this is what is FC. You are going to find that this is going to be a very high value. ખાલી તમને એનો meaning સમજાવી દો. You are going to find that this is a very high value. Okay, so what that really means is that number of collisions in 1 second for one molecule. Number of collisions in 1 second for one molecule is very large. Why is it very large? It's not that tough to understand, because it will move a very little distance and it will collide. એટલું જરાક ડિસ્ટન્સ મૂવ કરતા એને વાર ન લાગે, because if you find its VRMS, you'll realize that it's a big value. Okay, even VRMS is much larger. I don't know the answer. જે પણ હોય, I don't even care. ઓકે, તમારે કેલ્ક્યુલેશન કરવાનું છે. યુ હેવ ટુ મેક શ્યોર દેટ યુ ઓલ ગેટ ઇટ રાઈટ. ઓકે, અગેન નંદિની, આઈ ડોન્ટ કેર વોટ્સ ધી આન્સર. બરાબર, આ પર્ટિક્યુલર ક્વેશ્ચનનો આન્સર ફાઇન્ડ કરીને મને શું કંઈ નથી મળવાનું, રાઈટ? યુ મેક શ્યોર દેટ યુ ડુ ધ રાઈટ કેલ્ક્યુલેશન. તમે કન્ફર્મ કરવા માટે 2 વાર 3 વાર 5 વાર કરજો. ઓકે, ધીસ ઇઝ ફિક્સ દેટ યુ વિલ ગેટ અ વેરી હાઈ વેલ્યુ. આ પાવર જોઈને જ ખબર પડે છે, બરાબર ને? જસ્ટ બાય લુકિંગ એટ ધીસ પાવર્સ વી કેન સી દેટ ધ વેલ્યુ વિલ બી વેરી હાઈ. ઓકે, so that's it about collision frequency. You see, just keep this sentence in mind. Okay, collision બહુ બધા થતા હોય. It's a very violent place, if I say it like that. Okay, gases are very violent. Amongst the molecules there's like infighting going on, but we can't see that, interestingly. Okay, so now that's about collision frequency. Let's solve a couple of more questions that are related to gas law. આ ચેપ્ટરની થિયરી પૂરી થઈ ગઈ. ઓકે, કાઇનેટિક થિયરી ઓફ ગેસીસ પૂરું થઈ. પણ અમુક એક્ઝામ્પલ્સ છે ને બુકમાં એવા છે that we should do after doing thermodynamics, right? તો પહેલા એક્સરસાઇઝના 1-2 ક્વેશ્ચન કરવા જેવા છે which are based on gas laws. Let's do that. I can't do anything, Raj. ઇન્ટરનેટ ઉપર તો મારો કંઈ કંટ્રોલ નહીં ને. ઓકે, so let's go to the exercise question number 4. Okay, number 4. Exercise question 4. It's about some oxygen cylinder. Right. So let's begin. It says that an oxygen cylinder of volume 30 liter. Right, so there is volume. How much volume? 30 liter of a cylinder. Let's draw this, it might help you imagine what is going on. Let's say this is that oxygen cylinder. Bandh hoy, khullu nahi. It has an initial, means at starting it has gauge pressure. Hopefully you remember what is gauge pressure. So the pressure initial is 16 atm. Is this clear? Okay, and what is the temperature? What's the temperature? 27 degrees Celsius, which we don't like. So 300 Kelvin. Okay, so thank you. Now after some oxygen is withdrawn નો meaning શું થાય? આ સિલિન્ડર યુઝ તો કરવાનું હોય ને, તો એમાંથી ઓક્સિજન ગેસ કાઢવાનો હોય. ઓકે, not 15, 16. Gauge pressure આપ્યું છે. We don't use gauge pressure, we always use pressure in gas laws and everything, right? Okay, so after we remove the gas, right, some gas is removed, so now the new gauge pressure is 11 atm. So final pressure is 12 atm. All right, and the temperature drops to 17 degrees Celsius, that is 290 Kelvin. Yes, Ami, that's right. એવી રીતે જ આવ્યું. Okay, so this is what we know. Now what's the question? Estimate the mass of oxygen taken out of cylinder. Question clear? How much mass of oxygen was taken out? Okay, how much mass was taken out? કેટલું હતું એવું નથી પૂછ્યું. Please make sure you understand the question. Question is not how much mass is here. That's not the question. The question is how much mass has been removed. So you see, it's a very simple idea. Listen, suppose initially it was 10 kg, let's say, and finally it is 7 kg. Then we can say that 3 kg is removed. Understood? Yes or no? Yes, we will just find decrease in mass. Decrease in mass, that is initial mass minus final mass. Okay, so that's the plan. Now here, for the gas that is inside this cylinder, what remains constant? I'm asking you, what is constant for the gas? Moles are not constant. Volume is constant. Very good. That's right. The volume is constant. R is constant. એવો કેવો આન્સર હે? R શું છે? યુનિવર્સલ ગેસ કોન્સ્ટન્ટ ઇઝ કોન્સ્ટન્ટ. તો એ તો દર વખતે કોન્સ્ટન્ટ જ હોય ને. એનાથી શું ફરક પડશે? તો the value that or the thing that is constant for the gas is volume. Is that okay? This is clear? Now, अच्छा ये केम constant છે તો સમજાય ને, because this gas is filled inside cylinder. No, volume of the gas that is here will not change. See, we are only finding initial mass in the cylinder and final mass in the cylinder. So we are not talking about, right now we are not even talking about what happens to this gas. Okay, forget it. આપણો પ્લાન બહુ સિમ્પલ છે. પહેલા 10 kg હતું, પછી 7 kg હતું. સો વોટ એવર ગેસ ઇઝ ઇનસાઇડ, વી આર ટોકિંગ અબાઉટ દેટ ઓનલી. Okay, and because it is filled in the same container, volume is same. ચલો હવે વોલ્યુમ same. So what do you think we should do? If volume of the gas is same, what should we do? I'm waiting for your response. PV equal to mu RT. Yes, that is right. See, we can use the ideal gas equation to take a ratio. Okay, but it is recommended that you find mass first, because ultimately we want to find what is initial mass, what is final mass, and we want to subtract. એટલે માસ ફાઇન્ડ કરવા માટે તો આઇડિયલ ગેસ ઇક્વેશનથી ડાયરેક્ટલી જ કરવું પડશે, બીજું કંઈ રેશિયો ને એવું નહીં લેવાય. સો લેટ્સ સ્ટાર્ટ. સો ઇનિશિયલ. ઓકે, લેટ્સ બિગિન. So PIV equal to mu I RTI. Okay, I hope everyone got that. So mu I is equal to, or let's do one more step. Instead of mu, I'm going to write mass of gas upon m0. This is clear? Clear or not clear, everybody? Okay, chalo. So શું થઈ ગયું? mi equal to, we get PIV m0 upon RTI. Now similarly, if I want to find final, ઓકે, શું કામ મહેનત કરીએ બીજી વાર? બોથ ઇનિશિયલ એન્ડ ફાઇનલ ક્લિયર? બસ, તો હવે સબટ્રેક્ટ કરો. therefore mass of oxygen gas removed from cylinder is mi minus mf. See, subtract these two values, પછી મૂકજો. કોમન હોય ને, કોમન લઈ લેવાય, ઈઝી પડે. So what is common? V is common, m0 is common, divided by r is also common. ઓકે, જેને આવું ન ફાવતું હોય એ લોકો વેલ્યુ પહેલા મૂકી દે, પછી સબટ્રેક્ટ કરી નાખે. આઈ ડોન્ટ માઇન્ડ. ઓકે, બધી રીતે સેમ જ આન્સર આવવાનો છે. સો વોલ્યુમ, are we given the volume? 30 liter, yes, 30 liter, 30 into 10 raised to minus 3. Molar mass, આ ફોર્મ્યુલામાં મોલિક્યુલર માસ નથી, મોલર માસ છે. મોલર માસ ઓફ ઓક્સિજન ગેસ ઇઝ 32 gram per mole, because we are using SI unit. સમજ પડે કે નહીં? SI unit of molar mass will be kilogram per mole, પણ તમને જે વેલ્યુ આવડે છે એ ગ્રામ પર મોલ છે. Did you understand? આ સમજાણું ને? 10 raised to minus 3. So gram converted to kilogram. This is one of the most common mistakes. Okay, divided by R value 8.314 અને અહીંયા PI by TI અને એવી રીતે મૂકી દો. Now you see, whenever you will put pressure, ATM માં આપ્યું છે, so you will have 10 raised to 5 common. This 10 raised to 5 comes from ATM to Pascal. Okay, પહેલા કેટલું હતું? 16 થયું હતું ને? હા, 16 upon initial temperature 300 minus, એવું જ છે ને? હા, 12 upon 290. I hope all of this is clear. Okay, so now you have to just subtract and do all that. I'm going to leave that part for you. Don't forget the answer is in kg, right? Okay, let's go to the next question. Answer no આવે તો જોજો. Resha, we have already found the final mass. Have a look here. Volume તો બેનું સેમ જ છે. We are only talking about how much mass is inside the gas, inside the cylinder. Okay, instead of finding how much has gone, if we find how much is inside, then also we can get the answer, right? Okay, so this is it for this question. Let's go to another one. Exercise માં હજી એક છે. Yes, question 5. Question 5. આના પછીનો જ. Right, here it is. An air bubble of volume 1 centimeter cube. An air bubble of volume 1 centimeter cube rises from bottom of a lake 40 meter deep at a temperature of 12 degrees Celsius. Okay, lot of information given. Let's draw a lake. Okay, so suppose this is the lake, right? And where is the bubble? It is at the bottom, right? Okay, its volume is given. So initial volume V1 or Vij લખવાય. From there it rises, okay, from the bottom of a lake 40 meter deep. And at that point here, what was its temperature? 12 degrees Celsius. Question clear so far? To what volume does it grow? એટલે final volume find કરવાનું ને. To what volume does it grow when it reaches the surface, which is at a temperature 35 degrees Celsius. So from here, from the bottom, this bubble will go and reach here. Okay, here the bubble will become larger. Okay, તમે જોયું જ હશે. When a bubble comes up in water, it will become larger. So here we have to find what is its volume and how much temperature. Here the temperature is 35 degrees Celsius. Okay, so here first of all, to use any of the laws or anything, we should think what is constant and what is not. Is something constant here? Which quantity shall remain constant? Which quantity shall remain constant? Pressure? શું વાત કરો છો? કઈ રીતે? વંદન, વોલ્યુમ કોન્સ્ટન્ટ તો ફાઇન્ડ કરવાનું શું કામ કીધું છે ક્વેશ્ચનમાં? કંઈક તો યાર મગજ વાપરો. Yes, number of moles, that is mu, ka n જે લખો this mu is constant. Pressure will not remain constant, because hopefully you remember fluid mechanics. If it will go from bottom to top, the pressure will pressure will decrease, right? The pressure will change. યાદ આવે છે? Pressure variation with depth. અચ્છા, આ liquid શું છે? What is this liquid? Hurry up, come on. What is this liquid? Question વાંચો. Yes, it is water. Very good. So now this question is a mix of two chapters, right? I hope you understand why. Because we need to find what is P1 first. Question માં નથી આપ્યું. You need to find it by using fluid mechanics, and you also need to find what is P2, which is at the surface. આ સૌથી easy. Do you agree that P2 will be nothing but 1 atm or atmospheric pressure? Okay, now you find P1 on your own, and because mu is constant but pressure is changing, volume is changing, temperature is changing, so we have only one option, and that is this. Did you understand why we have to use this? Why we can't use any other law? You can also use PV equal to mu RT. પછી બેનું ડિવિઝન કરો એટલે આ જ આવે. I hope you know that. Okay, so 1 1 1 2 2 and 2. So just like that you will get this. So use this and get the answer. So the rest is for you to do at your home. Okay, goodbye everyone.